everyone, welcome back to the channel. I'm the GCSE science teacher, and in today's video we are starting a brand new topic for GCSE chemistry. It is quantitative chemistry, and if you are studying this currently, let me know down below, and also let me know what exam board you're using. Are you AQA, Edexcel, OCR, or are you something entirely different? I'd be very interested to know, and that way I can actually tailor my videos more so for your exam specifics. So first we're going to start off with a key idea in chemistry, and it's this idea of conservation of mass. Now, if you've done any chemistry already, you'll know that balancing equations is one of the things that you'll have to do for the exam. And the reason we balance equations is because of this idea, this conservation of mass law. Essentially, it states that no atoms can be created or destroyed, a bit like the conservation of energy law in physics. And the reason for this is because when a chemical reaction occurs, the chemistry of those atoms actually changes. So bonds are broken and bonds are formed. And it's essentially from the atoms that are originating in the reactant part of the equation. And then we form something new entirely with the products that are there. But the atoms remain the same. So there's the same number on each side of the arrow. And this is important because whenever you think about even fundamental equations in biology, as another example of cross curricular links, thinking about respiration or photosynthesis, you can see that the number of atoms on each side are the same. And that can help us with the following. So let's have a look. So, mass change calculations is something that you could get asked to do in the exam in chemistry. And it's based on this idea that mass does not change. So, for example, we have 10 grams of substance and we form two separate products. And that one of the products is weighing, or has a mass, I should say, of 7 grams, and the other is 3 grams, and that equals a total of 10. So, there's 10 on either side. Comment down below if you can tell me what the missing mass is. This is something you could be expected to do in the exam. And as the course gets ramped in difficulty, especially if you're doing higher combined or even triple science, they could ask you to do slightly more challenging calculations. And I'll get to that in future videos as well. So if we have a look here, we can say, why does it look like in some reactions the mass actually changes? And I've had lots of students ask me in the past, and also there are exam questions linked to this, that sometimes it will appear that the mass has actually changed. So we can see that we have an example of copper reacting and it forms copper oxide, and it appears to have gained mass actually in this example. And this is because copper oxide has formed. If we burn a metal in oxygen, if there's in a combustion reaction, often an oxide, a metal oxide will form. And essentially, mass has been not necessarily gained, but because the oxygen atoms have actually chemically combined with the copper, we now actually see the effect of that. We can see the mass has actually increased, but those oxygen atoms have always been in the atmosphere when we burn something. It's just that in terms of the actual mass of something, we don't necessarily see it at the beginning. And it's the same with how mass can also look like it's decreased in a chemical reaction. And this could as well be because there has been a chemical reaction that releases a gas. And if there's no, say, lid on the reaction vessel, the gas will actually escape into the atmosphere. And that way it can appear as though the reaction has lost mass. So that is something to be mindful of in the exam if they ever ask you, well, why does it appear as though mass has been gained or lost? And it's because of these two factors. Okay, so speaking of mass, we are now going to talk about how relative formula mass or even atomic mass is calculated. And you will need to know this regardless of what exam level you are studying. So if you're doing foundation combined, higher combined, or even triple single science, you will need to know how to calculate the relative formula mass and the relative atomic mass from the periodic table. So you might be thinking, why do we even need to know this? Well, in industries, in pharmaceutical companies, in the beauty industry, if you have to work out the mass of something, remember elements are actually useful to us. We have lots of different things that we want to synthesize as scientists that can be essential for manufacturing different things like beauty products, food products, even just down to household detergents. It's really important that we can actually use these chemicals in an appropriate way. And the relative mass of something is because those atoms are so tiny and small. We have to actually give them a relative mass compared to the atom of carbon 12, and this helps our calculations to be a bit easier to understand and actually utilize in a kind of like a mathematical sense. So First thing you want to know is the relative atomic mass is simply talking about the atom itself and how much the mass of that is compared to carbon 12. So if you look in your periodic table, which you will get in the exam, you'll see that each of the elements has a very specific couple of numbers. They have the atomic number and they have the mass number. Now, the mass number is how many protons and neutrons there are in that atom. The atomic number, however, is the number of protons or electrons there are. Remember, the number of protons and electrons is going to be the same in an atom because there is no overall charge. Now, if you want to have a bit of a recap about the atom in general, I have a video that I did, and I'll link that for you in the cards. So if I give you the example, we've got hydrogen, which would have the relative atomic mass of 1, carbon is 12, oxygen is 16, calcium is 40, sodium is 14, potassium is 39, and sulfur is 32. These are just some random ones that I've picked out for you. But you will only be expected really to know or be aware of at least the first few lines of the periodic table, the first few periods, I should say, the rows. You won't necessarily be expected to know loads of the other lower down elements, the heavier metals, that kind of thing. But like I say, you will not need to remember these numbers. You will be given this in the periodic table in the exam. So you can figure this out whilst you're doing the exam itself. But as you do these calculations, you start to remember some of them, which is quite cool. So that's the relative atomic mass. You can find out the mass of the atom. However, you will be asked to calculate the relative formula mass. And this is where things get much more um, interesting because you have to work out how many atoms of each element there are. And this is where students find it can get a little bit complicated, especially when there's brackets involved and things like that. So we've got a few examples here. For example, the molecule water, H2O, there are two hydrogens. Whenever you see a small subscript number like 2 next to the hydrogen, that tells you how many of that atom there is. So there's two hydrogens. And because there's no subscript number next to the oxygen, it's just one oxygen. Now, if we put a big 2 in front of the hydrogen, that would now times everything after it by 2. So we would have 4 hydrogens and 2 oxygens. And often in the exam, you could get a balanced equation and you'd have to work out the relative formula mass of that. And it may have a big coefficient, a big number in front of the whole molecule or the formula itself. And that way you'd have to times it all together. But in this case, we've only got one molecule of water. So we just do 2 lots of hydrogen, each having a relative atomic mass of 1. So it's 1 times 2, which obviously equals 2. And we have one oxygen atom, which has a relative atomic mass of 16. So we do 1 times 2 for the hydrogens plus the 16 for the oxygen, and we get a total of 18 for the relative formula mass. Remember, the formula mass is the actual formula, how much mass it is for that particular formula, not just the atoms. Often, by the way, relative formula mass has the symbol Mr, working out the Mr of something. Remember, the relative atomic mass will be the Ar. Just in case you see it in different textbooks or resources, that's just something to be aware of. If we have a look at the other ones, you can see we've got different examples, but when we start having brackets, as you can see towards the bottom, the brackets indicate how much of everything there is with the small subscript number at the side. So in the case of where there's a bracket, you want to times everything in the bracket by the small little number below it. And that way you can actually get the full amount that's there. So if I gave you the example in the bottom one, you can see that we have each and every atom in the bracket, we are timesing by a number outside the bracket. And that way you can get an answer of 74. One thing I will say, when you are working out these relative formula masses, I would recommend you write out every number with brackets around it. And that way, when you type it into your calculator, it's a lot easier to distinguish what is being times by what. You may also want to use a table method. That's something I've seen students do in the past as well. That can be quite helpful. So that might be helpful to you as well. Thank you so much for your time. I have been the GCSE science teacher and you have been curious. If you did enjoy the video, feel free to like and comment down below if you are studying quantitative chemistry at the moment, or maybe you're studying another topic. I'd love to hear from you. You can also subscribe, join the channel. It would be great to have you as part of our community here. And thank you for your support. Have a great day and I'll catch you in the next one.